We're back here at my office at the Copenhagen Business School, and here I'm sitting with one of the model brains I have here at my office. So as you can see, this is an approximate size of the brain. The brain is something like 1.5 kilograms heavy, and it has approximately this size here. Of course, there's no colors on the brain as we see here. The brain typically has a color like a mushroom, something like that. What we can see here are different bulges and hills, and it, from the outside, the brain typically looks quite messy in a way. What you can see are the hills here, for example, is what we call a gyrus, and the plural name for that is gyri. We also see some valleys, the ridges down here. We call them sulci. So one sulcus and several sulci, and there are some deep sulci, what we otherwise have been calling sulci, that we are so deep and going so much through that we call them fissures, like the one over here. Now, if you look at the brain here, it has a color system. Normally, this over here would be the eyes and the nose down here. You have the spinal cord coming this way, down to the body. We also can see what's called the cerebellum, a small part of the brain, relatively speaking, which is engaged in motor control, but we also know that it's involved in emotional responses and cognitive functions. But the function of the cerebellum is actually poorly understood. If we then look at different parts of the brain, and we grossly divide the brain into 4 different regions here, we can look at the green part of the brain here is what we call the occipital lobe, which is highly engaged when we have visual input. We have the yellow region here is the temporal lobe, which we know is involved in many things such as object recognition, object memory, episodic memory, even hearing and language is engaged in this region. We have the blue part of the brain here is the parietal lobe. We know that part of the brain is engaged whenever we are self-aware, for example. It's engaged in spatial movement and also in the dorsal stream function, as we talked about earlier, where we are looking at different functions that are related to actions, so to speak. And then finally, the frontal part of the brain, the frontal lobe, and even the prefrontal cortex is involved in many different functions, such as working memory, preference, decision-making, motor behavior, and so forth. If we take a different look at the brain here from this side, we can see that there's a strip here in red and a blue strip here, and they belong to respectively the frontal part of the brain and the parietal part of the brain. The parietal part this is kind of a sensory strip. It has a nice representation of the body. So this part of the brain here has a nice representation of the right side of the body. So whenever you feel something, you have a stimulation on your hand, for example, there might be some extra activation up here. If you then see that activation move up towards the shoulder, you actually see activation move up here towards this region over here. And in the very similar way, you also have a very nice mapping of the motor regions. So this means that if we now stimulate this part of the brain, we cause an activation in this part of the brain, the person might have a kind of a jump in his or her right hand. So this is kind of a nice distribution and mapping of your body, both in terms of the senses, but also in terms of your motor behavior. In terms of consumer behavior, when we are looking at different functions that the brain is doing while it's computing value, for example, or paying attention to something, we can see that different regions are important. For example, when it comes to visual attention, the parts of the back of the brain here, the occipital lobe, is really important for visual attention. So it could be visual saliency, it could be top-down modulation of what people are motivated to look for something. This can change the activation of the occipital cortex. When people recognize objects and products and even brands, we see a stronger activation of the bottom side here. We can actually take the cerebellum out. The bottom side of the temporal lobe is becoming more and more engaged, and we have a nice distribution of different functions here, that some regions here are thought to have a module that is dedicated to recognize faces, for example. If we then look at our ability to hold on to information for just a few seconds, this engages particularly the dorsolateral prefrontal cortex onto the sides here. And this is what we call working memory, but it also is related to a measure of cognitive load. So the harder you work on solving a puzzle and keeping information in your mind at any one time, the stronger activation we find in these parts of the brain up here. And then we can look at actually the inside of the brain. We can see that the yellow part here is the anterior cingulate cortex. On the medial side here, we see the spinal cord coming up. This is the pons, we have the midbrain. Then move on to the basal ganglia and the thalamus. If we look at the other side here, we can see that all these cortices, the occipital lobe goes into the medial side, the parietal cortex goes into the medial side. And we also see the frontal part is also going into the medial side. This is the orbital frontal cortex. The orbital frontal cortex goes all the way here. So this means that this is the medial towards the middle of orbital frontal cortex, and this is the lateral towards the side orbital frontal cortex. This small strip over here, which you also can see on this side, in blue, in yellow, is what we call the olfactory bulb. This is an area that receives signals from the nose directly and causes you to be able to smell, for example. So if you now lift off this part here and look into this area over here, what you can see here is the insula, which is kind of an oblong structure going on the inside. So it's kind of an insular part of the brain, as you can see. And now if we want to look at the part of the brain that is involved in memory and in emotion, you can see the brain from the side again here. What we can do is to lift off this part of the brain. We can take out this insular part of the brain. This is the hippocampus. And on top of the hippocampus, you would normally see the amygdala on top of here. You have the amygdala on top of here, then you have the hippocampus all the way back here. So there you go.